Hello everyone. In this tutorial we're going to continue off by learning how to add shooting and enemy behavior, which are the key elements of our gameplay in our top-down shooting game. And along with that, we're also going to cover how to track mouse movement and how to handle collisions. So let us continue. So I think the first thing that we should start from is making sure that our player doesn't walk off the screen, because right now he can basically walk wherever, and we want him to only move inside of this box that I drew out in our background image. So in order to do that, we need to calculate the positions of the bounds. And I have already sort of done that, so I'm just gonna paste those coordinates in. So here, what those numbers represent is the minimum bound on the x-axis and the maximum bound on the x-axis. Same thing for the bounds y variable, but only for the y-axis. So in order to make this all work, we're gonna open up our player class and we're gonna basically make an addition to our update method that we have in our entity and in our object classes. I'm gonna write update again, and in here I want to first of all call the update method from the entity class. I'm gonna do that by writing super update instead of our entity class. This is basically what's gonna be executed with this line. And now what I'm gonna do next is I'm gonna make sure that the x and the y positions of the character do not go outside the bounds. And we could do that easily with only two lines, one for the x position and one for the y position. So how do we do that? Well, we basically have to set the minimum and the maximum values for our x and y positions. You'll see what I mean in a second. So here I'm making the use of the min and the max functions, just so that our x and y positions do not go off the limits that we set. If we try and run this now, you can see that if you try to walk off the map, you would not be able to do so, because we're actually limiting the position of the player. So now that that's done, I'd like to visit the object class, and I want to add in another method, just because we're going to be using this method quite a lot throughout this tutorial. And what it's going to do is it's going to basically return the center of our object. So basically, the pivot of our object is by default the top left corner of the object. And with this method, we're able to get the exact center of where our object is located. Now that we're done with that, we're going to move on to tracking our mouse movement. And in order to do that, we're going to need to create a new object. So let's go back to this area where we left off a comment named objects. After we define our player, let's also define another object called target. And this object is just going to be an instance of our object class. And so for the width and the height, I'll probably give it like 50 and 50. And now we want to pass in an image. I already have an image that we're going to display, and it is located in this path. So now let's open up our game loop. Basically, this target object is going to be our cursor per se. And what we have to do is move this target object based on our mouse movement, or where our mouse is located on the screen. And Pygame has a special function for that, which is called Pygame. Now obviously this is a function that returns a tuple, so we're going to need to store it. I'm just going to store it in the variable called mouse pos. And after that, we're going to assign the position of our mouse to the position of our target. Now we also want to subtract the half of the size of our target. Otherwise, the target wouldn't be exactly on the center of our mouse, just because of how the pivoting of images work, as I explained earlier. So we'll need to write in here target width divided by 2. Let's do the same thing for the y coordinate. Alright, so if we now run our game, we'll see that the target is actually moving our mouse. But there is a slight problem, and it's the fact that our actual mouse is in the way of our target object. So a nice and simple fix to that would be to just set our mouse to be invisible. And as you may have already guessed, Pygame has a special function for that too, which is pygame.mouse.setVisible false. And I'm just going to do that right before the game loop. Now if you run this, as you can see, our mouse is gone. So now that you've learned how to track mouse movement, let's start to implement shooting. Now the way shooting is going to work is it's basically going to be a projectile that will launch from the player towards the target or towards our mouse. Let's define our shoot function right before our game loop. And we're gonna make a use of our target object. But first of all, inside of here, we're gonna need the center of our player. Just like so. And then what we're gonna do is we're gonna create a bullet object. So it's gonna directly spawn on our player position. And it's gonna have a size of 16 by 16. This is gonna be the image for it. And now let's get the center of our target. Now we're going to set the velocity of our bullet. If you still remember, we have defined a velocity field for our object class. We're going to make a use of it here as well. So basically, I'm setting the velocity of our bullet based on the target's center and the player's center. And this is done so that our bullet will move towards the mouse based on where the player is located and where the target is located. So now what I'm going to do is I'm going to create another list over here beneath our objects list. And I'm going to name it bullets. And let's go back to our shoot function and append our bullet to our bullets list. Now in order to call this function, we need to check for another event type, and it's going to be the event of mouse button down. It's just called the shoot function. Alright, so now if we run the game and try to press our left mouse button, you may notice that our bullet is quite fast. That is not really what we want, and as you can see, depending on how far it is, its speed is also changing. So we are going to need to do some vector math. First of all, we're going to get the length or the magnitude of our bullet's velocity. And this should give us the magnitude or the length of our bullet's velocity. And we're going to use it to essentially clamp or limit our bullet's velocity so that it doesn't change based on how far away or how close the mouse is in comparison to the player's position. Just like so. So now if we run this, you'll notice that our bullets are shooting at a constant rate regardless of where our mouse is. But the problem is they're quite slow. So let's multiply the velocity by a certain value. I'll give it 10 for now. And as you can see, our bullets are now much more faster. So now one more thing that we have to do for our bullets is we need to make sure that they don't leave the screen, because in the background of our game, those bullet objects still exist and we need to get rid of them. So let's go back to our game loop, and right after our loop where we update every single object, we want to make another loop. This time we're going to iterate through all of our bullets. Will be in bullets, and here I'm going to write an if statement in order to see if our bullets are actually within the bounds. And if they are within the bounds, I'm just going to write continue. But if they happen to be outside the bounds, then we need to delete them. And the way we will delete them is by just removing them from the bullets list and the objects list. Now if we run our game once again and try shooting, you can see that our bullets actually disappear when they touch the walls or the bounds. So the next thing that we're gonna do is work on adding enemies, because what's the point of shooting if we don't have anything to shoot at, am I right? So similarly to how I made the player class, I'll make another class called the enemy class. And I'm gonna derive it from our entity class. Now here, we're obviously gonna need to add our enemy to some sort of list that we can track later. And this is going to be important when we're going to be handling collisions. So I'll just create a list called enemies beneath our bullets list. Now let's add our enemy to the enemies list. Now our enemies are going to have a finite amount of health, just so that we're able to destroy them at some point after shooting them. So let's define a variable inside of the enemy class called health. And I think 3 would be fine for now, but feel free to adjust it to whatever number you like. And the next thing that we're going to do is add some additions to our update method. And then here we're going to write the logic for moving towards the player. And it's going to work similarly to how we calculate where to shoot our bullet, just because we're going to need the center of our player and the center of our enemy. I've went ahead and defined two variables, the player center and the enemy center, and now I will just change the velocity of this enemy object itself based on those two variables. And now, similarly to how we did with the bullets velocity, we need to decrease this velocity, or we need to normalize this velocity. So let me just go back to our shoot function and grab these two lines, and I'll just paste them below over here. And all we basically need to do here is replace the bullet keyword with the self keyword. Let's replace 10 with our speed variable. And there you go. And one more last thing that we have to do in the update method is call the update method of the entity class. Now let's go ahead and add another method, and it's gonna be the same one from our entity class. Let's go ahead and override another method called change direction. And here what I'll do firstly is call the change direction method in the entity class itself once again. And we're just gonna make one small addition here, and it's gonna be needed because without it, the enemy would only be facing either to the left or to the right, but not downwards or upwards, because our enemy would constantly be moving. If we go ahead and look at our change direction method inside of our entity class, the first thing that we check is the x velocity, and since our enemy is going to be moving constantly, the x value would never really be 0. What we will have to do is to make sure that sometimes our enemy looks downwards or upwards, and we could do it simply using. So if the y velocity ends up being greater than the x velocity or less than the x velocity, then we're going to change the direction appropriately to downwards or upwards, and it will work just nicely. Now let's go ahead and add two more methods. These are going to be brand new and exclusive for our enemy class. First one will be take damage, and all we'll simply do is just subtract the damage from our health. Easy peasy. But we're also going to have a destroy method. And if you haven't guessed by now, we're going to call this method once the health of our enemy is 0. Let's go back to our take damage method and check for our health. Alright, now in order to test this enemy class, we're going to need to create an enemy object. And I'm going to do that below our target object. I want to make a variable called enemy and create an instance of the enemy class. let's position this enemy at around 200 and 200 for the X and the Y positions. And the tile set will be, and as for the speed, let's make it 2. So let's try running this now, and as you can see we have our little enemy running. Now it's actually a little bit fast, but I kind of like it being that fast because it adds tension to the game. The only problem is we can't actually kill it right now, so how do we deal with that? Well, let's go back. Let's handle some collisions. So first of all, I am gonna go to our object class, open it up, and I'm gonna add another field in here. Let us call it collider. It's gonna be very useful for us when we would want to handle collisions between objects. So this is gonna be a list that will hold 2 elements, the width and the height. And this is gonna be important for us because we're gonna be adjusting it for our enemy, and we will do that right after we define the health variable. I'm gonna write self.collider equals width divided by 2.5 and the height divided by 1.5. The reason why I'm doing this is because the enemy's body isn't going to be equal to the width of the image. I mean, there is some space between the body of the enemy and the image's boundaries. So by dividing it, I'm actually minimizing it. So yeah, let's move on. And in order to add collisions, we need to make another function. I would do that below our shoot function. Let's close it off for now. And I'm gonna name it check collisions. Our first parameter is gonna be an object, and our second parameter is gonna be another object. So the first thing that we'll need is their appropriate centers. And we're gonna get them using those lines. We need to get the sizes of the colliders, so I'm just gonna write . Now brace yourselves as we're about to write a pretty lengthy if statement. I know this may look confusing, but I'm not sure if there is a point in explaining it, because this is basically a formula of how you detect collision. So we're basically using the centers of the two objects, and we're using the halves of the sizes of our colliders that are on the objects. If they're colliding, then this expression will be true and this expression will be true, and if it's true, it's going to return true. But if any of these expressions are false, then it's going to be false in the end, no matter what. Now we need to put this function into use, so let us go ahead and create one more for loop. That is going to be a for loop that will iterate through our enemies. And it's going to have another for loop inside of it, which will iterate through bullets. And here we're going to make use of the function that we had declared earlier, which is check collisions. And all we have to do is just write check collisions B and E. So we're going to be checking the collision between each bullet and each enemy and see if they're colliding. And if they're going to be colliding, then the enemy will take damage. We're going to make use of the take damage method that we declared earlier. And then all we're going to do is just delete the bullet from the bullets list and the objects list. And I'm just going to go ahead and copy it from the for loop that we made earlier, just like so. Now if you go ahead and run the game, you should see that our bullets are actually able to destroy the enemy. So in the next tutorial series, we're actually going to be working on how to make a spawner for the enemies, and we're going to add some UI elements as well as focus on adding some more polish to the games. And what I mean by that is we're going to be adding nice effects, and we're also going to learn some other stuff that Pygame holds for us. If you enjoyed this tutorial, please leave a like. If you want to see more content like this, then be sure to subscribe. And if you have any questions, comments, or concerns, please, as always, leave them down in the comments down below. And I will see you guys next time. Peace.